function f is given by f of x equals 4x cubed minus x to the power of 4. On what intervals is the graph of f concave up?
So concave up looks like this. So I'm going to find double prime. So let's start with the first prime. Derivative of 3 or 4x cubed is how many? 12x squared. And my next derivative is minus 4x cubed. Let's take our second derivative. What's the derivative of the first piece?
24x
24x. And my second piece?
minus 12x.
Minus 12x squared. And then we have to factor. So I'm going to set this equal to 0. And when I factor, I know I can take out an x on both. And what else can I take out? 12. So I have 12x. So I have remaining 2 minus a what? X. And I like parentheses. So we have possible point of inflection. And if I set this one equal to 0, what is my x? Okay. If I set that one equal to 0, my x is
2.
So then let's make our number line. We have 0, 2. And you can test any numbers you want, but why not be clever and test 1? And what about this one right here? -1. What about here? 3. And we're testing it into this point right here. So when I plug in -1s into my first fraction, or not fraction, parentheses, we get a negative. What do I get in my second one? Positive. So negative times a positive is a negative. So it's concave down. And then for the 1, when I plug it into my first set, I get a positive and another positive. 2 positives being multiplied is a positive. So we have concave up. And then for testing 3, it's going to give me a positive and a negative. So concave what? Down. And which one is going to satisfy the condition?
C.
C. Boom. Okay, let's go on to number 26. All right, Presley, let's read number 26.
What is the value of x at which the minimum value of y equals 3x to 4 with 3 minus 2x occurs on the closed interval 0 to 1?
Okay, so since we're looking at the minimum, we're looking for when y prime is equal to 0. So we need to first derive. So when I derive the first piece, when I take 4/3 times 3, what eliminates? The 3. So we have 4x. What's 1 less of 4/3? 1/3. And then my second part of the derivative is simply minus what? 2. So that part is calculus. The remaining is probably algebra or even pre-cal. So 0 is equal to, we have 4x to the 1/3 minus 2. So I'm going to do two things at the same time. I'm going to add 2 on both sides and divide it by what? Okay, so when I do, I get the x to the 1/3 remains. And 2 over 4, I could go ahead and write out what? 1 over 2. Now we're looking for the x value. It says what value of x? X is not by itself yet. So listen carefully in case this part was a struggle last year. If I want to get rid of 1/3, can I multiply by the reciprocal? So 1/3 reciprocal is 3 over 1, or simply 3. And that's going to eliminate everything on the top over here as just 1. So when I cube the 1, we get how many? 1. When I cube the 2, I get how many? 8. And voila.
So we just cube it.
All right. Let's now go on to number 29. 29 is not even a calculus concept. If y'all remember graphing rational functions last year and also in Algebra 2, that would be great. But if you forgot, that's okay. So here we go. Okay, vertical asymptotes. Does that happen on the top or the bottom? Okay, bottom, all right. So we're going to elaborate everything on the bottom. And let's go ahead and start factoring. The top is not further factorable. Leave it alone. Isn't bottom difference of 2 squares? So we have x squared minus 4, x squared plus 4. Which part can I further factor out?
X squared minus 4.
This one only. There's no such thing as sum of 2 squares. If you think it is, you're making up math. So then I'm gonna leave the top as it is. The bottom, this piece, I can further do difference of two squares, x minus 2, x plus 2. And then the other one, just leave as it is. So let's see what is happening here. Is there a hole? But am I asking you to find the hole here? No. So we know we have a vertical asymptote right here at x equals negative 2. For my second piece, let's kind of mentally do the math in my head. If I said x squared plus 4 equal to 0, we're going to first subtract 4 on both sides, right? And then we're going to square root negative 4 on both sides. Can you square root a negative?
No.
It's an imaginary. This right here is an imaginary number. So therefore, how many vertical asymptotes do I have? Just one.